And I think ours was 10 meters high, right?
It was, the water level was 10 meters high.
Yeah, 10, okay. Okay, first of all, I wrote it down wrong. Hold on. It's 10 meters high and the water is 8 meters. And it doesn't make any difference. I mean, you can still do, make another problem if you do it that way. And then I wrote it down wrong, I'm sorry. All right, so, well, this one matches. 10 meters. 10 meters. And the water is at 8 meters. Yeah. The water is at 8 meters. So I'm going to put a jigger right here. Well, no. I'm going to do this. And I'm just going to, cover that up. Okay, so the water is at 8 meters. And water density is what I tell you, 1,000 kilograms per meters cubed. And the density is 4 meters. And I think that's it. Yeah. And I think yesterday we pretty much got, take this. There. And before class ended yesterday, I told you to set up the similar triangles. And I think we got it to, it's not drawing with this. All right, what's the dimensions on the big triangle? 4 and what? 10. And this one is R and what? H. And that H goes right here. Hold on, what does that look like? 6. Hold on, make it 8. So 4 over 10 is equal to R over H. 4H is equal to 10R, and divide by 10, divide by 10. So 0.4H is equal to what? Now RH is not going to be H all the time. Most of the time you're going to change it to H minus 10. I'm sorry, 10 minus H. Because of that 10 right there. So, but just for purposes, setting up, this is good. So now you know that this guy is equal to 0.4 H, so 4/10 of whatever this is. So there's your related rate. In other words, let's say when your distance right here is 2 meters, what is this? Well, it's going to be 0.4 of 2, which is 1/8, or whatever it is, whatever comes out with it. See, when you get to 3, your radius is going to be a proportion of 3. Whenever you get to 4, your relation is going to be 4 to this. That's your related rate. Okay? Now, that's to set up that. And see, this is the hardest part right here. Once you get that established, then the rest is just, what do we got to find? We got to find this plunger, and this plunger has a dx or dy, whichever one you want to use, since you're going in the right direction. Some people use dy, some people use y right there. Does it matter which letters you use? No. So don't get hung up on that. So, this plunger here, we know that the area of this circle is pi r what? Pi r squared. And we know that this height is dx. So if we was to write the area of the plunger, it's going to be pi r squared dx, right? So the area of the plunger area of the plunger. Let's do this. Let's call this step 1. Okay, step 1 is finding the related rate. Step 2, area of the plunger, or area of the disc, whatever. And that's going to be pi r squared dx, or delta x, or dx. Now, there's only a couple of things that I need to bring up. And that's the, what are we working with? Sorry about that. What are we working with? And we find out that we're working with what, kilograms? So that means we got to worry about mass. So we've got, first of all, work is equal to what? Force times distance, right? And force is equal to what? And of course we got our volume. And volume, or mass, is equal to volume times density. But you know that from your physics, and you know that, plug each other that. So now all we have to do is set up our antiderivative from 2 to 10, because we're moving 8 meters from 2 to 10, and set it up, and it'll be mass, let's see, force times distance. Now, the distance. This distance right here, you need to take it away from the 10, or the 10 minus the 8. So make sure you make that distinction for the distance, or the displacement. So let's write all that down, and we'll go to the next page and do that. 10 minus 8. Yeah, 10 minus 8. Tell you what, let me just erase this. And it'll be the volume is going to be equal to the pi r squared delta x dx. And there's your r. Now what is my r? Well, it's going to be r is 0.4h, but what is h? Like I said, it's 10 minus h. Remember 10 minus h? In other words, you got to change this into some kind of, so that'd be 10 minus h. You can change this to y if you want to. 10 minus y, whatever. Alright? So the h right there is going to be 0.4. Pi r squared is going to be 0.4 parentheses, 10 minus h. All right, clean that up. And it might be better for you, you don't have to rely on a calculator, if you change 4/10 into what, 2/5? Might be easier for you. 2/5. And that way, that would be what, 4/5? So it'd be easier to work 4/25. So what we're finding here is the volume of the what? Of the disc. So I guess you call that number 3. Sorry. Volume of the disc. Pi r squared dx. So that would be 4 pi over 25 times 10 minus h quantity squared. So the volume of the disc is equal to 4 pi over 25 times 10 minus h quantity squared dx. And that's the volume of the disc. Now, part 4, mass. That's the volume times the density, right? So that's pretty simple. So let's go to the next page, and I'm going to take this with us. I'm going to take the whole thing. Mass is equal to volume times density. Mass is equal to volume times density. In other words, that plunger, you got to think of it as being filled with water or being part of the water. So that's going to be equal to this 4 pi over 25 times 10 minus h quantity squared times 1,000 dx. So that's our mass of the disc. Just like, remember the chain, or the rope, or the cable, same thing. We had to find the mass whenever we had kilograms. We had to multiply it by what? 9.8? Well, there's 9.8 right there. Okay? Now, take that, multiply it by that, and what do we come up with? Mass of the disc is equal to 25 will go into 100, what, 4 times, so what is that, 40? Somebody cancel that out for me. I think it's 40. 40 times 4 is 160. Y'all check my math. and telepathically let me know if I'm right, because y'all ain't gonna talk. And now you need to multiply that by the 160 times 9.8. And that's going to give you what? 1568? That's what I got. So force is equal to 1568. Y'all check my math. Times 10 minus h quantity squared dx. And now you're ready to set up your interval. Because that's it. The only thing you need to do now is just, you can change that to x or y or whatever you want to. It doesn't really matter. You're going to take the derivative of it. So you're going to use the chain rule. So let's take this and copy it. Move it over. Let's just take that front part off. And make it a antiderivative from 2 to 10. And just for I'm just going to make this an x. You can make this dy dh. You can make it dh if you want to, or you make this x. I don't care. Make that x. Now you're ready to start. Pull out 1568 pi. Antiderivative from 2 to 10 of 10 minus x quantity squared dx. So, what do you do right here? What did we do when we did integration? We reviewed over integration, and you've got a shortcut right here. What do? You do shortcut number 2, which would be 100 minus 20x plus x squared, right? Yes, no, yes. Thank you. So W, or W, depending on where you're from, 1568 pi, antiderivative from 2 to 10 of 100 minus 20x plus x squared dx. And now you can break it up into 3 antiderivatives, or just do it in your head, whichever one you want to do. I love technology. Huh? I didn't hear you. I did what? Yeah, that 2 is too high. Let me erase it. Thank you. Nope. going to give us W is equal to 1568 pi. And what I would do, and I would just draw a bracket right here, 0 to 2, 2 to 10. And that's going to give me 100x minus 20x squared over 2 plus x to the third over what? 3. And then of course that goes to 10. So we have W is equal to 1568 pi brackets 100x minus 10x squared plus 1/3 x cubed, evaluated at 2 and 10. Finish her out. I don't even know if I finished it. Yeah. See what y'all get. So that's going to be W is equal to 1568 pi. And that's going to be brackets 100 parentheses minus 10 parentheses squared plus 1/3 parentheses cubed minus, put that in parentheses, minus parentheses, all that again, 100 parentheses minus 10 parentheses squared plus 1/3 parentheses cubed. And we're going to plug in a 10 here and 2 here. I don't even know why I tried. See y'all? That King of Jordan's taking care of business, ain't he?
Yeah, it's a shame we can't do the same.
You read about mine. You know what he's saying to the world though? He's saying we ain't got any leaders, so I'm just going to take charge of this.
I hope that, I feel like ISIS probably miscalculated when they killed him.
Because he thought that we were going to act like the U.S. He thought that Jordan was gonna act like the US and go, oh, well, that's bad, that's terrible, but we're not gonna do anything.
Or like the Iraqi soldiers, whenever the reason ISIS was able to take over all these cities is because they scared the crap out of
Exactly.
the Iraqi soldiers.
They thought they were just gonna walk in and just,
mutilate.
I think
So that, even with ISIS being outnumbered, they still win because everybody was turning around.
Yep.
But
Jordan's not gonna do that. And certainly not Israel. So, Israel's just chomping at the bit. Israel reminds me of a bulldog on a chain.
Well, see, ISIS
that chain never gets broken. Oh my gosh.
ISIS won't mess with Israel because if they did go into it, it would be over.
Oh gosh, Israel will make a parking lot out of it. All right, 100 times 10 is what? 1,000 minus. Well, what's this? 10. So that's 100 times 10, which is. Isn't that nice? Plus 1,000 over 3, which is 333, blah, 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 but I'm not going to do it. I'm just going to put 1,000 over 3. I'm just going to do that right now. Minus, what is this? 200 minus, y'all don't have to tell me, I can't read my own writing. Is that 400? 2 squared, is that 400? No. 40. And then plus 1/3, I can't even, what is that? 1/3, that'd be 8. 8/3, help me out. 8/3. Alright, y'all check my math against y'all because I'm doing it. I should just pay attention to my paper and just do it like that one time. One of my bad things, I'll put my notes down and I'll just do the math and I'll end up messing up. But, does everything look good? Of course, these two go out, I think. Not sure. And that leaves you with W is equal to 1568. And that's going to be 1,000 over 3 minus, and we need to clean up all this. So get a common denominator of 3. So that'd be 600 over 3 minus 120 over 3 plus 8/3. W is equal to 1568 pi. 1,000 over 3 minus 600 minus 120 is what? 480? 488 over 3. Dang old 1568 pi. Dang old 512. Might help me out. $170, somewhere around 170.7. Somebody do this math for me. What does it come out to be? And it's metric, so it's going to come out probably, what, joules? Hang on. Is that the way it's spelled? Somebody take that out. I cranked it out. I got 3.4 times 10 to the 6th. Y'all check me. Huh?
1568
Divide by 3.
Yeah, that's what.
I mean, is that what you got?
No,
Okay, I know what it was. I think hold on a second. Go back to one. I want to see that 100k minus 20x squared. Yeah, I just I made a mistake on my notes this time. I said on my notes that was, I got 20x squared, and I just dropped the 2 off. I don't know why I did that. Dropped it. So, and I didn't even put a 3 there. I did on the next step, but it was too late. Fine, I'm sorry. That would be, what'd you get? Because mine's wrong on my notes. So what'd you get?
It'd be
840 kilojoules. So, showing you this problem. Now, of course, I put in, there's probably, what, 15 steps? Probably 5 of them you can do without. Do without. But I'm showing you every single step. So, what do we do first? 1. Of course, you draw a picture. 2. Set up similar triangles. Now this is a conic now. This is a conic. Alright? 3. Now, when I say 3 a while ago, when I said 3, I said, what are we working with? What are we working with? What does that mean? Well, are you working with standard units or are you working with metric? Does that make a difference? Yeah, it makes a big difference. You don't have to do as much multiplying with standard. Alright? You need to remember that work is equal to force times what? Distance, Hubert. That's right, class. Thank you, class, for being interactive. And force is equal to mass times gravity. I know I'm going to have some physics person say I'm doing everything wrong. Mass times gravity because of the dang old metric in this one. Now, of course, standard you wouldn't have to do that. And mass is equal to volume times density. And of course, you need to get the volume, and that could be right in here. I should have put that. I'll put that 4. Volume of, I call it the plunger. You can call it the disc, whatever you want to call it. And that's going to be based on pi r squared dx. And remember that you just put a note out here. Note h will usually be in respect to the height, which is like 10 minus h. You need to remember that because that'll get you. And then once you get, of course, you see that this, right there, once you get this worked out, and you put it in there, and then you've got your distance, then you can set up your antiderivative. So let's do nerd. I've got plenty of them. Let me tell you. Here's one. I wanted to do a standard. Let me see if I can find a standard. one of the ones I've seen so far. I do a bunch of these. At least the ones I don't mess up on. Get one out of my notebook. Here we go. Let me get my handy dandy picture. See if I can do this again. Here. Alright. Dang old radius. Hold on a second, I'm going to try to. Well, that don't look good, but you get the point. Dang old radius is 8 feet. Half full, and I'm looking for a height. Hold on just a minute. 16 feet. So take out the dang old pin here. Dang old 16 feet. Y'all are impressed, aren't you? I knew y'all would be. I'm gonna fix this one too, though that looks terrible. What happened to it? Really? Can't do anything nice, can I? There. Looks terrible, but there you go. And it's half full, and I'm just going to write the directions over here. OIL density is 50 pounds per cubic foot. Buick. Is that some kind of car? Brick. Oil density is 50 pounds per cubic foot. The tank is half full of OIL. And they want to know how many pounds, or how many foot-pounds it's going to take to empty the tank. Yeah, half full is 8. You know it's, well, you know that the OIL is 8 foot. No, because you're not doing as much because it's in standard units. Basically, you just got to take the weight and, the volume and multiply it by the density. Volume times density. And it's going to be from 8 to 16. Well, yeah, you still got to do that because you don't have R. R is changing. that plunger, think of the plunger at the bottom and going to the top. What is R doing?
Yeah, you have to value
What do you mean the values of H and R? You don't know them. You know H. You know the. No, I know what. I see what you're saying. No, the OIL is half full. In other words, this H right here, just ignore this H. Ignore that. This is OIL. Okay, right here. Half full. That one, you can say this is about half full. All right. The H that you're talking about, H is equal to where the plunger is. I know that's not probably good grammar, but in other words, H tells you where the plunger is. Okay? Now, as H goes up, what is that radius doing? Okay, so you've got to figure that out. So you've got to set up the similar triangles on all conics. You have to do that. Is that what you were asking?
No, I was just saying, this time we didn't have to do, we knew the initial value of our, whereas last time we had, it was also different.
I'm confused. Well, you're not giving R on this.
You know where it starts from, which is,
Well, we did where it started on the other one. It started at 2. I mean, it had to. Because you had the air. Remember, you had the air. It's got to start. You got to get that air taken care of. So it's got to push that air out. So you start from 2. Your plungers will start at 2, and then it's going to go to 10. All right, that's the integral. That's this part. That's so this one's going to start at what? 8 to 16. Okay, because it's got to push that air out. Here's the hole. All right, it's got to push that air out. So when that plunger's right down here, and it's going to grow because it's pushing that OIL, and then once it gets to about right here, that air is what? Gone. So from 8 to 16, you're going to be pushing. Now, what are you going to be pushing? You're going to be pushing that what? That plunger, right? That plunger. Don't get this mixed up with that plunger. For this problem, the blue part is OIL. That's your blue part. Now, right now, that OIL is up here now. It's right up here, flush with this. In other words, if you push this just a little bit, it's going to start pumping out OIL. So right now, we've got to figure, because this is air. All right? Right now, we've got to figure this, and you always have to figure this volume here. And the way that you do that is by the what? Similar triangles. Maybe I'm just not understanding your question. When we get through with it, maybe you can help me out. 8, 16, and you can call this H because that's where the plunger is. H over R, and that is 8 over 16 is equal to R over H. So 16R is equal to 8H, and 16, so it's 1/2, right? R is equal to 1/2 H. Now, what is our H going to be? H is going to be what? 16 minus H. Or you could say 16 minus Y. I don't care. So, pi R squared, the volume of the disc, or the plunger, is equal to pi R squared dx, or dy, or whatever. And then right here, what are we going to put in right here? 1/2 what? 16 minus what? H, or x, or whatever. Now there's your volume of your disc. Now take that volume and multiply by the what? Density, Hubert. That's right, class.
Did you have to worry about, accelerating?
Not with standard. So that's going to be, what's our 50? Is it 50? Yeah. So I'm just going to go down here and put my 50 with it. So that's going to be 50 pi times 1/2 16 minus h quantity squared. That whole thing is quantity squared. dx or dh. Let's say dh. You don't have to do that. You can say y, dy, you can say x, dx. And you're going to have some calculus teachers that have to see it. Listen, if you get, what are you looking for? Are you looking for an h or are you looking for a number? You're looking for a number. Alright? You're going to end up doing what with that variable? Plugging in what? Plugging and chugging. Does it matter? No, it doesn't. Alright, set up your integration. Dang old 8 to 16, plug that in and take off. How is the best way to learn these things? Well, after you do about 5 or 6 of them, you'll have it. I promise you. Or you just challenge and you have to go through it. Okay? I was challenged. Y'all need to cheer up. Y'all act like y'all been in a funeral this morning. What is it? It's 8 to what? 16? Take off my handy dandy equal sign. And I like x's, so I'm just going to take this off and change this to x. Just personal preference. There's one thing I can do before I pull out the 50 pi. What is the one thing I can do? The 1/2, you know, square it, and then you can pull it out. The W, or W, 8 to 16, 50 pi, and that's going to be 1/4 times 16 minus x quantity squared dx. And of course I can pull that out of that. So now W is equal to 50 pi, what's 50 over 4? No, that's what we said. 50 over 4 pi antiderivative from 8 to 16 of 16 minus x quantity squared dx. W is equal to 50 over 4 pi antiderivative 8 to 16 of 32 minus 32 x plus x squared. Somebody check my math. Dx. 16 times 2 is 32, and then 2 times 16 is 4. Yeah. Huh? 16 squared is what? 256. The minus there. Alright, now, this is going to be a cluster, so better save some space. 50 over 4 pi, and then that's going to be 256 x minus 32x to the second over 2 plus x to the third over 3, evaluated at 16. 256 parentheses minus 32 times parentheses squared over 2 plus parentheses third over 3 minus 256 parentheses minus bracket minus 32 parentheses squared over 2 plus parentheses q over 3 close bracket close big bracket. Why did I put brackets around the second part? Because that negative right there, and I don't want to see you do 90% of the problem right and get 100% of it wrong just because of that negative. So 16, 8, 8, 8, and yes, you're going to need a calculator unless you're Rain Man. You're going to need a calculator to do that one. So I'm going to copy that over to the next page. Copy the whole page. Doesn't matter what I do. Did it take out? Can I call a program a jerk? That wouldn't sound right. User unfriendly. How about that? So that's going to be W is equal to 50 over 4 pi brackets. 256 divided, or somebody give me that first part. What do y'all get when you do this first part right here with the 16? Anybody got it yet? Okay, I'll do it with you. Now don't tell me what you got while I'm trying to do it, because that ain't gonna help me out, man. It's gonna mix me up. 247. All right. So 256. Let me turn it on. There we go. 256 multiplied by 16, close parentheses, minus parentheses, 32 times 16 squared, close parentheses, divided by 2, close parentheses, plus parentheses, 16 squared divided by 3. Oh, 16 cubed divided by what? 3? I got that. What'd y'all get? Okay. So store thing old alpha. What is that? Numerator or first? That'll be first. Thing old F. Where's that? All right. And then this one is going to be parentheses 256 multiplied by 8, close parentheses, minus parentheses 32 multiplied by 4 squared, close parentheses, divided by 2, close parentheses, plus parentheses 8 to the third, close parentheses, divided by 3, close parentheses, and that should be it. I got 1962. Is that what y'all got? Oh, I see where the problem is. I got a 4 right here. So second function, entry, back, change that to what, 8? Can't read my own writing. That's pretty sad, isn't it? I got 1194.67. All right, so we'll store that at the stove, and that's going to be alpha second. Or this on this thing. And that negative is going to make. Oh shoot! Did I subtract? Did I do it correctly? Let me look. Minus. Okay. All right. So it's going to be minus. So that'll be alpha first minus alpha second. I got dang old 170. Dang old times 50 times pi equals divided by 4. I got dang old 6,700 pounds of 6,700 foot-pounds. Yep, that's what I got. Is that what y'all got? Huh? Well, y'all feel good about yourself. And hopefully you're feeling a little bit better about this. What were those numbers, those two numbers right here? Just round them off to the whole number. What was it? I'm sorry, what?
The first one,
1365 dot minus what? 1194 dot. And then we came out with 6701. What was it? 6702. Okay. All right, let's try nerd. Do another dang old metric. Y'all don't get too excited. That's like a mint green, isn't it? I ain't worth a crap when it comes to colors. I guess that's why I didn't, oh well, that's pretty much. That looks good. Still sucks. Alright, 4 meters. I can do the white without any problem. That's how anybody in here, artist? Anybody? Y'all suck too, huh? Alright, and the height, total height is 5 meters. And the liquid inside is 3 meters. I'm just going to make this blue the liquid, and we're going to put it right here, and then I'll draw a disc in it because the liquid looks blue, so I'm going to just consider it the liquid. So we're going to take that H out, and we're just going to make it the height of the liquid, and I'll draw a plunger in the problem. The liquid is at 3 meters. Of course, what kind of liquid is it? Well, I'm going to tell you in just a second. It is water, and water is 1,000 kilograms per cubic meter. I didn't do the math on this one. I just set it up, so we'll do the math together. Chances are, when you do this one, if you had problems doing the first one, chances are you aren't going to have problems doing this, as many problems, because you're going to feel a little bit better about it. And you're going to take the smokestacks off your truck when you go outside. Okay, I'm bringing y'all biscuits next time. I can't handle this. I'm going to get Muhammad Gabadi in here to take care of y'all. Well, y'all about to put me to sleep. I bet you know which kind of tank problems you want on the test. Standard or metric? Yep. Maybe this will help you out. Yeah, just come on in. Yeah, that's fine. Just bombard into our class. That's fine. be coming up here.
Sample problem.
Of what? What kind of sample? Give me, oh my lord. I have to pull one up. Let me pull one up for you. Right quick. Let's see. Let me freeze this. And look. You'll have to come copy it down. Let's see. What chapter is this? 3. Yeah, 3. There you go.
I got my neighbor waiting on me, so I'm gonna do this, and then I'll just tweet the rest when I get home.
Okay. What time you gotta leave?
Oh, she's waiting on me now, but
Wait, do you have time for me, after I get through with them, I can do it on the spreadsheet just a few minutes? And that way you can check your numbers.
okay.
You got a calculator, haven't you?
Yeah, my phone.
Okay, you're gonna need it. Just get the columns set up. All right. Y'all done yet? Now, I was trying to, gosh, well, there we go. Okay, that's pretty much it. Final step. Set up integral with parameters. In that case, it's going to be from 0 to 3. Yeah, because once you get up, yeah, take 2 away, take 2 of the air out, then 0 to 3. So that'd be, in this case, 0 to 3. That was right. I'm trying to do this some kind of order, but I know some people are very sequential. All right. The volume of the slice. Well, first of all, we got to find the similar triangle. So I'm going to go right here, and I'm going to draw my plunger. And you can say this is dy, and the radius here we don't know. And the height here is in direct relation to the R, but what kind of relationship? So 4 is to 5, as R is to what? H. 5R is equal to 4H. Then we'll divide by 5. R is equal to what? 4/5 H. Is that what y'all got? Now that H, of course, is going to be 5 minus Y. So the volume of the slice is going to be pi R squared H, or pi R squared H, and H is dy. So volume of the slice is pi R squared dy. And R is equal to this, but with that H, I'm going to put in a 5 minus H. So 4/5 times 5 minus H. Now it's going to be 16/25, right? So what do we do here? We take this and combine it with what? Density, which is 1,000 kilograms per meter cubed. So it's just going to be 1,000 times that. So that's going to be 16/25 pi times 5 minus H quantity squared multiplied by 1,000 dy. And then what do we do with the force? We do that here and here. Pull this out here. So that's going to be 9.8 times 1,000 times 16 pi over 25 times 5 minus H, quantity squared, dy. And then that's pretty much it. The only thing is, you can, what I mean by putting this all together, basically just right here. Was that 9,800, 16 pi over, so you put all that together, or you can just leave it whatever. Because you're going to end up pulling it out anyway. So then you can pretty much do what you want to do there. Down here, let's think about this. To get this air out, we got to move up how many places? 2. So right now that plunger is sitting right about, about 2 right here. So that means that right now the water is sitting right here waiting to what? Waiting to come out. So that plunger is sitting at 0 and it's going to what? 3. 3 to 0. That's the way I think about it. Now, some people may think of it different. That's the way I think of it. Because when that plunger is sitting and that water is sitting right here waiting to come out of this hole, that's 0. And then moves up 1, moves up 2, moves up 3. So, set it up. 0 to 3. Huh? I'm going to let y'all come up here and draw on this line. What do y'all think? No. 9,800. I'm just going to do this. 9,800 times 16 pi over 25 times 5 minus H, quantity squared, dy, dh. I don't care. Let's see, I'm going to change this to x and d. You can have h dh, you can have y dy. Now, the 9,800 times 16 divided by 25, has anybody done that? I didn't do it because I didn't do the math, I just set it up. So take that and multiply all that out. Somebody give me a number. Just, okay, let me, let's take this and copy the clipboard, next page. All right, what'd you get? 6272. 5? Oh, okay. And 0 to 3 of 5 minus x. Let's just skip that step. Thing over 25 minus 10x plus what? X squared dx. Huh?
That whole quantity should be x squared. Because when you change the values from 0 to 3, if you would have left it like going from 2 to 5, and you would have done 5 minus x squared and then did substitution, you would have got the value 0 to 3, but you would have, or you could have plugged the value and got 0 to 3, but it would have just been u squared du. And since you're only going from 0 to 3, you should only have to go to the increment of the height instead of 5 minus the height.
I see what you're saying. So we just need to call it x.
Yeah.
Okay. All right. I didn't even think about that. You're right. Since I went ahead and sorry about that. Since I went ahead and compensated for the air being in, I think that's you're right. I don't like that. B. Yeah. Since I compensated for the air being pumped out and I started at 0, basically this height is going to be x or h or whatever. So you don't have to take it away from the 5. So this would just be x. Is that what you're saying? Yeah. Didn't think about that. I'm sorry. Luckily, it don't hurt anything except just take out the x. Limit 5. So that would be x squared dx. How about that? That better? So that would be 6272 pi evaluate our time brackets x to the third over 3 evaluated at 0 and 3. Of course 0 takes out anything. So 3, that's going to be 27 over 3, right? Which would be 9. And 9 times that, what does that come out to be? 9 times 6272 pi. And somebody tell me what that comes out to be. 56,400 what?
448 pi.
Which is going to be what? They know close to 180,000. Something like that, 60,000 times 3. Quite a bit of work. All right. Now, once you do a couple of the conics, then you can move on to your spherical or your cylinder. Here's one. Let's see if I can find a cylindrical tank. Cylindrical. I don't know how to spell cylindrical. That don't look right. Hang on, that's close enough. Anything's better than me drawing it. Let me put it to you that way. Alright, just ignore, oh, well, I'm not going to worry about this right here. That ain't going to let me cut it off either, so just ignore that. We've got a tank, and this tank is 12 feet in length. That sucks. .12 feet in length. And it has a radius of 4 foot. And it has a pipe coming out of it. Now remember, the plunger can't go through the pipe. Plunger, or in this case, this plunger right here, it can't go through the pipe, so you got to take that into effect. Let's go with a pipe that looks like this. And I'm trying to draw it so y'all can understand what's going on. There's the pipe going out. That pipe is 10 foot. So the pipe is 10 foot. And you're pumping out, we'll say, but I don't know, I think it's gasoline. But I'm not sure. I don't have the density. I didn't write down the density. We'll just use water. Okay, you got a water tank and you're pumping out water. Well, we don't need the density, do we? Yeah. I didn't write down all the information. Yeah, here it is. 42 pounds per cubic foot. 42 pounds per cubic foot. So that's the density. I just didn't write density out beside it. So I guess it's gasoline. 42 pounds per cubic foot. And I'll give you what they want in just a minute. 42 pounds per cubic foot. That's the density. And evidently the tank is full. Yeah, I don't have anything that says different. The tank is full, and they want to know how much work will it take to empty the tank. Now I didn't say empty the tank and the spout, I just said empty the tank. Pushing up from the bottom, so your dang old plunger is now changed from a circular type to a what? A rectangle, yeah. So it looks something like that. I know this is gonna work like a balloon in a punch bowl. Lead balloon in a punch bowl, yeah. That will work real well. Oh. Forget it. Just forget it. I give up. It's all Bush's fault. Try to help y'all out. This technology just don't work. So of course when something don't work for you, what do? Do you quit or do you blame it on somebody else? You blame it on somebody else, exactly. Just trying to draw it where you can at least see. Oh, forget it. I give up. Alright, so this one's going to have a width, a length of 12, and a width. Wait a minute, what about the width? How are we going to do the width? Well, you're going to have to think about how you're going to do the width. Because you're going to have to use a squared is equal to b squared plus c squared. And set up a proportion like this. So the first thing I told you to do on the conics is find your proportion for your triangle. Well, what's happening here is you've got your circle. We're looking at it like this. And you've got that plunger, and the plunger is right here. Now, set up your direct proportion. And this is going to be, we'll just call it, we're not worried about, this is going to be called H. And this is going to be called what? R. Now, anything having to do with that circle, a squared plus b squared is equal to c squared. Dang old looks like you're setting up a dang old triangle. So you use that to get you started. Think of what is the diameter. What is the diameter in relation to the radius? What is that? Or you could take the diameter and divide it by what? 2, right? That maybe help you out a little bit. Look at it like this. You can make this, let's see, c squared is equal to, or b squared is equal to c squared minus, b, or a squared is equal to c squared minus b squared. And you could say that w, or diameter, we're just thinking, okay? Diameter over 2, ain't that the radius? Is equal to 4 squared minus, and that would be h squared. Based on that right there. Now, in order to understand that, you need to think about this relationship. You know, let's go from the beginning, right in the middle. Let's say that you're right directly in the middle of this circle. Alright? You know that this, when it's at the middle, you know that this is equal to 4, and this is equal to what? This whole distance is equal to what? 8. At that point. So you can use that for your direct proportion. I mean, if you wanted to. In other words, 4 is to 8 as R is to this distance right here. But when you plug it into that, you're going to end up getting the same thing no matter what you do. Right there. And that's your relationship. Just remember, whenever you have a cylindrical tank, you're going to be using that right down there in the bottom left-hand corner. So solve it for W. Or in this case, I'm sorry, not W, D. Solve it for D. Right here. So let's take that over here. And solve it for D. So how do you undo a square? Take the square root. That's right, class. Thank you. So D over 2 is equal to the square root of 16 minus 8 squared. Multiply both sides by what? 2. So D is equal to what? 2 times square root of 16 minus 8 squared. So now you've got your diameter, which is this line right here. And that's the way you're going to set up anytime you do a cylindrical problem. I mean, on the side. That's the way it's going to be set up. So now we've got D. We've got that. Now let's look at the don't look at my drawing yet. You get the concept. We've got the length. The length is what, 12? And we've got that the height is dy or whatever. The strip is dy. Length times width times what? Height or whatever. So this right here is this right here. 2 times the square root of 16 minus 8 squared. So what is the volume of this strip? This times this, right? So the volume of your slab, whatever you want to call it, is equal to 12 times 2 square root of 16 minus 8 squared times dy of the edge. Now you've got the volume. Now what are you going to do now? You got to find the force. Force times distance equals work. And that 12 times 2, that's 24. And then what's our density? I guess it's gasoline. What did I tell you it was? 42. And then you're going to put it all together and set up your integral. And we'll finish that. We'll finish this problem. It's going to be -4 to 4. Why is it going to be -4 to 4? Anybody want to take a stab at it? Well, look at your, oops. If your radius right here is 4, and what's the only other way for you to put this? Okay, y'all get the point. What's the only, if this is 0 to 4, what can you put for this? -4 to 0. So you have to think of it like that. That's what gets you on the inverted tank, is this right here. Alright? Okay, y'all had enough. I think y'all brains about fried. Y'all ain't even talking.
Is that when the water level drops?
Hmm?
The water level going down.
Pushing it out the top right here. So you got to push from the bottom up. Okay, let me